No doubt. I know some of you going to college. Let's see. I know for sure Ontiveros is going to college. Quintero is definitely going, I think. Valencia, I'm not sure who's going to college here, but you're going to see this again. When you take statistics, a standard college statistics class that everyone has to take, whether you're a liberal arts major or science major, you're gonna delve deeper into this, what I'm covering. Because this has to do with the real world, how probabilities are calculated, how predictions of the future are calculated, with all sorts of phenomena going on around us. And I talked about how in reality and in nature, it's like there's a mysterious thing going on. When things happen randomly by chance, so to speak, it behaves this way. The histogram that's formed becomes symmetrical, and once that happens, we can make predictions about the future. It's powerful stuff, in other words. We see this in nature all the time, and the rule is called, yesterday I named it the 68, if you remember yesterday, the rule is called the 68, 95, 99.7 rule. Okay, that's what we called it yesterday. But there's also another name for it. Phone's away, thank you, I have the floor. Another name for it is called, on your warm-up, go to write empirical rule. Sometimes people refer to it as the 68, 95, 99.7 rule. Other people refer to it as the empirical rule. It'll be on the quiz this Friday for sure. Why empirical? Well, I'll get into the reason why it's called the empirical rule when we get into our notes today. But let's just finish off this warm-up. But before we finish the warm-up, let me tell you the game plan for the day. It's pretty straightforward. We're only here for an hour today. Since it's a shortened period, I'm making it very straightforward today. After I answer this phone. Thank you.
Where's that at?
Village Career Center, Village Academy Career Center. So, what's the game plan? We have a shortened day, like I was saying. So I'm gonna get right to the point, since we only have an hour. Here's what we're gonna do. We're gonna take notes on my lecture. You have yesterday's note guide. If you don't have yesterday's note guide or you lost it, I have some extra copies because we only did one side. We're going to do the other side right now, that other curve. C25, week 2 Wednesday. Watch this. You're going to take notes on the warm-up, which you're about to do right now. What else are you going to do? Well, what you're going to do also is you're going to take notes on the live lecture. You're going to do one guided practice problem with me. I'm going to walk around and you just make sure that you let me know that you're understanding what I'm teaching. So it's a guided practice problem. All number 1 to 3 is for your R stamp. If you want your P stamp, you're going to go to Big Ideas through Clever. It's an online assignment. It's only 5 problems based on what I'm going to teach today. So Clever is this on your Chromebook. It's right here. I know you guys have seen Clever before. You log in with your Google credentials, and you're going to look for this. It says it's like a B with an I inside. Big Ideas. You click on that puppy, you're going to see C25, the assignment, and then you're going to go ahead and start it's an online assignment where you type in your answers. It gives you 3 tries. If you don't finish before the bell rings, you can finish it for homework. Make sure you save your work though. On the upper right hand side by your name, make sure you save and exit. Because if you exit, it doesn't save your work unless you press save. Please don't just exit. Save and exit if you don't finish before the bell rings. So it's just some notes, one guided practice problem that you show me that you know what's going on, and then go off and do your Big Ideas online assignment. That's for your P stamp. Let's rock and roll. Unless there's any questions. All right. One second, give me one light switch. So look what I got on the board. I'm going to leave it up here the whole week and even next week. I have the empirical rule. Mu is the mean, the middle of the data, whenever a symmetric histogram is realized. And it just so happens In nature, in reality, when we got a symmetric histogram, one standard deviation above, look at that's the mean plus a standard deviation, and one standard deviation below, that's the mean minus one standard deviation. 68% of the data is always going to be within one above and one below. Always. It's just some freaky fact of reality. 95% of the data is going to be 2 above and 2 below. And then almost 100% will be 3 standard deviations above and 3 standard deviations below. This is what we went over yesterday. For those of you watching the video, this is what we went over yesterday, right? 68, 95, 99.7 rule. Okay? So far, so good. What percent of the data is shaded? Valencia, I saw, what'd you put? 34%. Did anybody else get 34%? Thank you, Quintero. Thank you, Fonseca. One of you three, what was your reasoning? Divide 1 in half specifically? Right. Look at you guys. What I'm going to shade in orange is 68% of the data. Between 1 above and 1 below standard deviations is 68% of the data all the time, if it's a symmetric histogram. And I'm just asking for the green portion. So just top 68 and a half, 34% of the data. Beautifully done. Simple logic. It's not that difficult. Let's not overthink this. Go ahead and bust out yesterday's notes from yesterday. Remember we only did one side? We're going to do the other side right now. Bust that out while I play this day in history. The 68, 95, 99.7 rule. Okay, that was yesterday's notes. And what I'm telling you now is that sometimes it's called the 68, 95, 99.7 rule for obvious reasons, but sometimes it's called the empirical rule too. Now empirical, I studied philosophy in college. There's a philosophy called empiricism. It's a philosophy of life that says that which is true is only that which can be sensed with one of your 5 senses. Let me say that again. That which is true is only that which you can perceive with your 5 senses. And that's called empiricism. You don't have to write this part down. I'm just going off into a little philosophical rant because I studied philosophy. That was my major, philosophy. But think about that. Is that truth? Is truth only that which you can perceive with your 5 senses? Who holds to that view? None of you? So none of you are empiricists? Truth is only that which you can perceive with your 5 senses. One second, phone. Help me. That's empiricism. So empirical means, hey, what we see in reality with our 5 senses, whether it's cockroach sizes, height of giraffes, weights of dogs, shoe sizes of men, it always comes out to be a normally distributed data set. It always comes out to be a histogram that's symmetrical, where what's normal, the average is in the middle. You'll have some people that are above average or things that are above average. So certainly you're going to have some cockroach that's larger than normal. That cockroach is like above average size. Sometimes cockroaches are smaller. My point is, whatever we study in nature behaves this way. So they call it the empirical rule. That which we perceive with our 5 senses. That's what empiricism is. It's freaky. So, empirical rule, aka 68, 95, 99.7. Let's do our first example now. All right, here we go. So you're on the other side with the blank curve here. And let me get example 1 down here. So you're going to need this paper and 1 extra paper of your own because we're not going to be able to fit all the examples in this one piece of paper. So go ahead and get another piece of paper out too, because we're gonna fill this up right now with some examples, but you're gonna need more space. So get another piece of paper out. Here we go. So go ahead and write number 1, 2, and 3 down on your note guide. You know, to save time, don't worry about given and an approximately normal distribution, because they're always, all of them are just given like assuming an approximately normal distribution. Just save some time. Just put what percentage of all values are less than 1 standard deviation from the mean. Because they're all assuming that we have a normal distribution. It's not skewed to the right or to the left, just to save some time. What percentage of all values are less than 1 standard deviation from the mean? Let's go ahead and label our normal distribution. Right, 1 second, there should be, computers are for later, dude. Right now you're with me here. Here we go. So the mean is 70 inches, going to put 70 right there. That's where the mean always goes. Remember, mu is now the mean from now on, not x bar. Because we're dealing with populations and not just samples, and we're going to get into that later. All right, this is 1 standard deviation above. So that would be men who are 73 inches tall. I'm adding 1 standard deviation to the mean, so this is 73 inches. 76 inches would be 2 standard deviations above. And then three more, another standard deviation, 3 standard deviations above would be 79 inches. All right, this is the average height of men, about 5 feet. 0.8 times 12. 0.8 times 12. So 5 feet 9 inches actually. 70 inches is 5 feet 9 inches tall. That's the average height of a man. And you have some are above average, some below average. How about 1 standard deviation below average? So I'm going to take 70 minus 3. That's going to be 67 inches. 2 standard deviations below. 67 minus 3 is going to be 64 inches high. And then minus another 3 is going to be 61 inches tall. So there's the normal distribution of male heights, of adult male men. So far, so good. So, look at question 1. What percentage of all values are less than 1 standard deviation from the mean? Well, we know that 68% of all men are going to be within 67 and 73 inches tall. So, the answer number 1 is 68%. 1 standard deviation above or below? So I just came up with a random example for this one, just male heights. And this is true. 68% of men, all men, are going to be within 73 inches or 67 inches tall. Most men are around that on average. What percentage of all values are less than 2 standard deviations from the mean? Okay. So from here to look at 2 standard deviations, that's going to be 76 inches tall. And 2 standard deviations below is 64 inches tall. What percent of men are there? Well, that's 95%. Pretty straightforward for now. Right? So that's 2 above, 2 below. And last but definitely not least, I'll put the last one in blue. 3 standard deviations from the mean. The mean is 70, so 3 standard deviations would be 79 inches tall. And then below average, 3 standard deviations is 61 inches tall. So what percent is that? Well, that's going to be the 99.7%. So far, so good. Pretty straightforward, right? Those are the easy questions. We're going to get a little more difficult now. Slowly easing our way into this. So far, so good. So problem D. What percent of men are between 64 and 67 inches tall? Write that down. All right. Let's look at our distribution. So what we're interested then is this part of the data. I'm going to highlight it in blue, baby blue. What percent of men is this right here?
34.
34. Let's see. Does anybody disagree or agree with whoever said that? Who said that? Cruz? Who said that? She's up. Go ahead, Cruz. It's all right. Okay, so that's the question. What percent of males are that? So he's saying 34. Anybody agree or disagree?
It's 13.5.
Who said 13.5? How'd you get 13.5, Mr. Fonseca?
For this, in between the two standard deviations.
Yes, in green.
Yeah, and then you divide that by half, and then you take away 34 for the half.
Woo! Fonseca's rocking it. All right, look at Fonseca's reasoning. He says, look at, we know that 2 standard deviations above and below is 95% of the data. And what he did is, you know what? Let's just focus on this half of the 95. Look at this half right here. He wants to focus on that, so he divided that by 2. And what you get when you divide 95 divided by 2? What you get there?
42.5.
Yeah, so it's 42.5%. In other words, look at half of it now. Let me get a little highlighter better. This half in yellow.
Wait, no, it's 47.5.
47.5. Yeah, I figured as much. So this half in yellow right here, right here. Fonseca got the 95. Divide that puppy by 2, and he gets 47.5. Make that a 7. Okay, but I don't want that whole half. We're just interested right here, that little sliver in the baby blue. What you do then, Fonseca?
For the 68% between the two, I mean the -1 standard deviation and +1.
Yes.
And you divide that by half again, and you just take away.
Right. So notice. Let me use red. We know from here to here is 68%. Right. 1 standard deviation above and below. If we chop that in half, we did that for a warm-up. Valencia got that for us, and Quintero and Fonseca. We know that this red part is 34%. So the yellow and the baby blue together is 47.5% of the data. The red that I just highlighted is 34. So if I take the 47.5, subtract the 34%, this sliver, I'm gonna get what's the baby blue area, the area between 64 inches tall and 67 inches tall. So it requires some thinking here. In other words, Fonseca is really using this rule. You gotta get very acquainted with the 68, 95, 9.7 rule. You gotta know how to manipulate and get these intervals down. So what did that become, Fonseca? 13.5%. So he took the 47.5 in green, look at all this is in green, this is all 47.5, because that's 95 divided by 2, and then he subtracted the 34%, which is half of 68, and that gets us what we're interested in right here. This part, we're interested right here, between 64 and 67. So that's 13.5%. Very nicely done. Wow, I'm impressed. So 13.5% of men are between 64 and 67 inches tall. We don't even have, we don't have to go and investigate all men to figure that out. All we do is take a sample of men that's rightly done. And how we take that sample of men, we're gonna get into that soon. But this is how statistics is done. Cool. E. I'm gonna wait on these for now. Problem E, here we go. What percent of men are taller than, watch this now, 73 inches tall, are taller than 73 inches. This is the last one for the day. What percent of men are taller than 73 inches? In other words, I'm now focused on right here only. I'm focusing on that data. What percent of this is that data? What percent of men are taller than 73 inches high? Don't even give it a shot. See if you can reason your way through that. We know that everything, the whole curve is 100%. The whole thing's 100% of men. I'm focusing just on who's taller than 73% or 73 inches. You got it already, Fonseca, or not yet?
Yeah.
What? That quick, man? Fonseca's on it. Hold up. Let's see.
Are we stopping at 79 or going all the way?
Well, there's still people who are taller than 3 standard deviations above the average. Those are like say the Shaquille O'Neals, right?
Yes.
Of the world. A very small percentage of men are that tall, but they go past 3 standard deviations. The whole curve is 100% of men. So what percent is larger than? What percent of men are taller than 73 inches high? What you get, Fonseca?
16.
Okay. Monteveros, what you get?
I didn't do it yet.
No worries. Cruz, what you get?
I didn't do it yet.
No worries. Write it down. Quintero, anything? It's okay if you didn't. Martinez? Valencia? Not yet? Okay. I'll give you a few more minutes. So I want to know, this is the last one for the day. What percent of men are taller than 73%? Given the 68, 95, 99.7 rule, there's a way to figure this out. Chew on that for a little bit more. 1 second. Hold up. Here we go. You ever do this before, Fonseca? So how'd you get 16%?
From the 95, it's between the two standard deviation, and then the 99.7 is the 3, but since we're going all the way, then it's the 100. So 95 minus 100 is 5, and then divided by 2, that's 2.5%, and then you add the 13.5, so you get 16.
Hey, you're going to get a little, I love, because there's different ways of getting it. I say, I follow you. But if I tell the rest of the class that's a little too convoluted, but you got the right answer. How about this, you guys? What percent of the data am I shading in right here? Watch. Let's go pink. Here's the mean. Look what I'm going to shade in right now. What percent is that? Anybody? Someone besides Fonseca. That's 50% of the data right there. Okay? So I already know this is 50%. What I just shaded. That's half the data. All I need now is this part. But we figured this part out on warm-up, huh? What's that sliver between the mean and one standard deviation above? 3 of you did that. What was that percent again? That's 34%. In other words, from here to here is 68. So 68 divided by 2 is going to be right here. That's 34%. So really, at 73 inches tall, 50 plus 34% of men are shorter than that. Look at 50% plus another 34% of men are shorter than 73 inches tall. I'm adding up the green and the pink. That's 84% of men. Follow my reasoning. 84% of men are shorter than 73%. That's the pink and the green. But my question is, what's greater than 73? Well, if 84 is shorter then the whole thing's 100%. Let's take 100 minus 84. That's going to give you 16%. So this part right here is going to be 16% of men. So 16% of men are higher, taller than 73%, or 73 inches high. So all this lesson is just manipulating the 68, 95, 99.7 rule, getting used to it. It's not going anywhere soon. For the rest of the time, get started on the assignment. If you don't finish, that's fine. It's on the online assignment. We end at 55, so we got about 13 minutes till class ends. Go to Big Clever, then Big Ideas, and start a few of the problems online. If you don't finish before the bell rings, save and exit. But we're done for our notes for today. Go to the online assignment, rocking and rolling.